Okay, so I've been told that I can just start. So I will just start. And I get to give strange talks in places, and this is really something that is a different kind of talk. And it is about discovering Christopher Alexander's properties in your code. And that's some OAuth code for loading gists. And, whoops. Okay. And in your life. Okay, so I challenge you to, for those of you who are thinking about code all day, that this is going to be half about thinking about Alexander related to the code you write or the code you read, and the other half is going to be about your life. Christopher Alexander, in case you don't know who he is, how many of you have heard of software patterns? Not everyone, but Software Patterns community. We just had our 20th anniversary conference this year in September. And I happen to have been writing patterns for the last 8 years. And Christopher Alexander he's still alive, a building architect who had grand visions for how people should make livable structures. So cities that have life, small rooms that have life. Universities that have life, great building places, meeting places. And his work actually inspired people, the first patterns, people who made the connection to software. And Alexander wrote a book about a timeless way of building. But the first people who wrote about software patterns were inspired by his work. And they were at Tektronix. And I remember I worked at Tektronix as well, as Alan did. And there was this guy, Ward Cunningham. How many of you heard of Ward? Yeah. Okay. And Kent Beck, and they were trying to write these patterns for how to do good software. And they were doing it with Windows. You should have 5 plus or minus 2. They were actually very bad patterns, the very first patterns. I'm glad the rest of us have kept going. But since then, Christopher Alexander moved on, and he's sort of a tortured soul. Not many architects in the building architect world understand him, but us software people who like interesting ideas have embraced the idea of writing patterns about good software design. But Christopher Alexander produced 4 volumes. I have all 4 of them. I have only read 2.5. Okay. And he has 4 volumes on the nature of order. And the very first volume is one on 15 properties of things that have life. And the second one is the process for creating lively things. And I'm going to be talking about that today. Okay. Now, this is my friend Jenny Quillian, and she has written a book that it's called Delight's Muse, and it's about Christopher Alexander's Nature of Order, and it's really nice to read. It is on Lulu. If you want to read, and a lot less expensive, a lot more approachable, I highly recommend Jenny's book. She's a good friend of ours. We spent time at her casita, in her house, and talked about Christopher Alexander. So let me talk about his properties of things that have life. Now, remember, Christopher is a building architect, not a software architect. So he's talking about physical things. And 2 key important ideas are the idea of wholeness or completeness and centers. Okay, so let me talk about that. I don't want you to read this in great detail, but one of the things that says there's a class of entities, isn't he a small talk guy, right? All right, which I call centers, appearing everywhere in space. They appear where they do as a result of configuration which appears in the world. So there are things in space, and whether it is very small or very big scale, there are lots of centers. So you can look at centers in the design of a chair, or in the design of a building, or the design of a city. There are many centers at those different levels of scale. And he says, yeah, it's the system of centers, so it's the whole thing is about systems of centers, is fluid and changes from time to time as the configuration and arrangement and conditions all change. Still, at any given moment, these centers form a definite pattern. This patterns of all centers appearing in a given part of a space constitute the wholeness of that part of the space. It is this structure and the wholeness of it that is responsible for its degree of life. Okay, so something that has this well-formed, well-proportioned set of centers that relate to each other, and the way they relate gives things life. And so, not to be an expert about this, but Jim Copleen, who spent time with Alexander as he was writing the books, his 4 books, and Jim Copleen is well known in the object community. He said, well, in a user interface, there's graphical elements, and software depends on what we consider to be the equivalent of geometry, space, and structure. And I'm going to talk a lot more about that. But I hope you also think about in your life as well. Oops. Okay. So I'm going to go through these 15 properties, and you can look at it, and it's good to have names for things. One of the reasons why I like patterns is because I could give a name to something and say, oh, let's use a strategy pattern here, right? If you understand what these properties are, and you look at, let's say, code or your messy room at home, whatever, you might see whether there are centers there and what makes things more pleasing, more But Joe really appreciates beauty too, and so I convinced Joe that we would go to the ancient city of Kyoto before the conference. And so I took all these pictures here that I took of Kyoto. It was a very lively place. And I didn't even know when I was taking this tree, like, it's got a face, right? It's smiling at you, but this is a tree. Okay? To me, it looks very alive. And so anyway, one of the first things that Alexander talks about is levels of scale. And so if you think about a big ball of mud, there's no different levels. It's just all, right? That's why we don't like them. It's really hard to untangle. But if you're thinking about things that have nice structure of scale, is that usually you have a 2-to-1 or a 3-to-1 relationship between smaller things, and then you jump up to the next size and the next size. And so here's a picture actually of a tree that over hundreds of years this is a giant tree that they had done bonsai. And each tree branch area was kind of shaped by these other smaller structures. And the ratio that Alexander observed in physical things is like a 2-to-1 or a 3-to-1. So just to give you an example of that, I don't want a very tiny window and a wall, right? A little tiny window and a big wall, not very good level of scale. I want to have proportion. In software, and I'm going to talk a little bit about software as well as life, we think about design. And we like to break things into smaller pieces, like modules, right? Or classes, or methods. And no class or object or method, or if you're service-oriented kind of programming, should be too big, right? And you assemble them into components or subsystems. And within a subsystem, you don't want too many objects either. And then we are building systems of systems, and you still have to structure stuff. You have to think about that. So we naturally do this. And actually, one of the things that people do is when they see something that's not well structured, we have some names for this levels of scale problem. You've heard of the godlike object? Have you heard of that? That's where it has everything, there's no other things around it at the same level of scale. So, having things well proportioned. So this, to me, is one of the most profound levels of scale that I ever saw in my life. In code, the smalltalk collection hierarchy. I don't know if you have had that experience just looking at that bit of code, but to me, it almost brings tears to my eyes thinking about it. And there's a set of decisions and questions you ask about it, but are elements ordered or not? And then there's a branch that talks about, are duplicates allowed, or can we test? Are they sequenceable? Is there an obvious ordering or not? And then we end up with these set of classes down below, bags and sets, where we don't have duplicates not allowed, but yes, in the set not. Okay. And there's all answering these set of decisions. You see when you go down one path that maybe there's 2 to 1 based on this and 2 to 1 based on that. And yeah, there was a lot. Maybe there were too many arrayed collections. I think so. But the ratios changed based on the decision points in these questions. And then, if I think about the levels of scale, I have 3 abstract methods as building blocks where I can add, remove, and do something. And I inherit all this wonderful behavior, and they implement all of these things. And the level of scale is just built on these 3 representations. Then all of these are done in terms of those, collection primitives that are inherited. It's just like beautiful levels of scale. Now, anyway, so to me, if I think about the collection hierarchy, when I first learned about objects and design, I went, wow. All right, it was like, wow. Because that was a good level of scale, what you could do. Now, I would like to write hierarchies of classes that were this beautiful. You don't always. It's so hard. It's not always that I'm trying to strive for this, but when you see it, it's a word competing. So, let's talk about your life a little bit. Get back to people, not just code. My good friend Linda Rising is co-author with Mary Lynn Manns about fearless change patterns. And those are about patterns for making change in your business world. And it was interesting when I started thinking about levels of scale that I saw different levels of scale of some of those patterns. There's a pattern called elevator pitch, and that is a high-level summary of the kind of change that you want to initiate in your company. And then there's a town hall meeting where there's a lot of people, and then there's a single personal touch. Those are different levels of scale. If I think about music, we all like music. Should have tango in here. I don't know a lot about tango, but you think about pieces and movements and tiny like I say, music memes that go in your head, riffs, phrases, or beats, and those are at different levels of scale. And then if we think about an orchestra and the different strings or brass or woodwinds, or just the roles of people in that, they're all at different levels of scale. So again, this is taken at Kyoto, and one of the other properties is that centers are strong. And they're symmetrical shapes complementary to the whole. And so there's all kinds of symmetric stuff going on here. We've got this underpinning of this, and these are, repeated down here. And it's just really a very beautiful architecture. But let's get back to software. What are our centers in software? I think well-defined roles, or what objects play, and patterns of interaction form centers. When I think about when I was thinking about what good small talkers do as they program and design, certainly just understanding interacting roles and patterns of interaction are important because the objects themselves that are controlling and coordinating them also form centers. If you think about models, usually it's kind of a network structure where some entity holds on to another smaller, lesser objects, if you will. And there's relationships between the names as well. Even when you just go and look at the bits of classes and inheritance hierarchy, you could think of the abstract class as being a center upon which other things extend. And even algorithms can have centers, particularly if you use things like template to replace stuff. All right, so these are two books that I know very well. Having written them, I write a book about once every millennium. It's 1990, 2002.
That's the pattern.
Yeah, that's a pattern. Okay. And so I want to talk about some of the centers that we thought about when we were writing this book. By the way, this cover was designed by my brother. This is back before there was UML, so we had to invent classes and subsystem. And it looks like now I'm postmodern, because this is actually an artist that I really like, and his work that it's kind of made out of glass as well. But anyway, so one of the things that we had in this is that looking at centers, and this was, I think I wrote a Smalltalk report article back in 1992 or something like that, that there were typical behaviors when you look at an application, and I came up with 6 of them. Information holder, which is an object that primarily just holds on to information. A more complicated one where it maintained the relationships between with the structure. There was service providers that do work. An object reader, write stream, does work. Something that coordinates or controls and interfaces between different layers or parts of the system. And these kind of roles seem to interact. Now, when I wrote that Smalltalk report article, I thought that there might be more than 6, and I said, oh, you can come up with more of these if you want. No one ever did. So they seem to be pretty fundamental and basic. So the idea also, and this was in the second book that I wrote, was the notion when you look at code, as it executes, the control centers that exist. And that's, if you think about objects, and there's a cockpit of a airplane. I can't fly something that complicated. But a control center is a place where objects coordinate and control others. And if you look at it, you can think about a centralized control, which is what someone might do if they had a controller doing all the work and just changing the state of information holders around it. So that's when someone, I think, is not very object-oriented. They tend to say, oh, I'll just have one big object that does the work and data. I don't know if you've seen code like that, but a centralized control would be like that. Some more delegated style that you learn once you get into Smalltalk is like this. And this is my first impression of Smalltalk. I couldn't figure out where any of the work was getting done this first time. It's just calling it, and eventually a primitive happens, right? Magic. Okay. Okay. Now, talking about Alexander's properties is the third one is about boundaries, where you need to separate things out just to make sense of the world, and it encloses and strengthens centers. So this is actually a picture of, they actually take care of their trees a lot in Japan. Right? This tree had all these, strengthening and making these branches strong. There's posts. And there's, okay. So the idea of having boundaries between things. This happens to be a boundary between bubbling hot springs in Yellowstone and outside where Ellen and I went on a vacation and took that picture. We need boundaries because things interact. And so if we think about Smalltalk, even though it doesn't have the notion of public and private methods, we still need to separate out what should be called from outside versus what is implementation detail. And in my language of, not of choice, but I've had to program in Java for quite a few years, the notion of an interface or defining good interfaces is very important to make sense out of things. Again, we can think about other kinds of boundaries. It's that the tests today are kind of a way of defining boundaries between what we expect out of the program and what we get out of the program. I don't think that some people like to think of tests as being specifications, but I think they're not complete. They are just defining parts of the boundary that should be visible. Sometimes if we are building class hierarchies and we can extend a class, we can think about subclasses and superclasses and the relationships between how do I extend it if I'm using a template method, what steps can I replace. If you're familiar at all with Eric Evans' work in domain-driven design, he has the notion of aggregate roots, which again are these structuring objects that then they provide a boundary, and you can only access parts of an aggregate through this root object. It's a way of having a very structured, stylized way of getting parts of something. And he also has boundaries. He talks about an anti-corruption layer. So if I have two domains, set of classes interacting, and I don't want them to kind of get muddied, I can define a layer between them that does those sort of translations. And that's a way of defining boundaries. Okay. So I already said about aggregate roots, but essentially this is a silly example, but if I want any access to a car is only through the car, and you wouldn't get wheels and positions and tires through that. You talk to this object. Now, that all sounds great in theory, but when you start programming and really having domain models that are rich, it gets very ugly. You see that you have aggregates talking to other aggregates that are aggregating other things, and levels of scale and all this sort of stuff start playing in as well. So this is a picture of it was too early, these are plums, not cherry blossoms, because it was early spring when I went to Kyoto. But there were just these waves of trees that we went to a temple and we looked out and it was just going on and on forever. Alternating repetition, you can see the branches, and it was just amazing. I think about alternating repetition. This is my colleague, Joe Yoder, who likes to dance a lot, and you lead and you do things, and you understand the repetition of that. Me, I'm more of a solo artist. I run, that's me. At the Hippie Chick half marathon. It's an all-women's half marathon. Now, when I'm talking about alternating repetition in my life, it's like I don't run 10 miles every day. I wish I could. I don't. What I try to do is to run 3 or 4 times during the week, a shorter distance, be 5 kilometers, 7 kilometers, 8 kilometers each time. And then on the weekend, I try to do a long run. Not as far as you, but I want to get up to be able to do half marathon length on the weekends. And so that's a repetition. That's a pattern. And when I'm injured, I have to slow down. I do different things like walk. And sometimes the runs are tempo runs, where you try to go at a pace that's slightly uncomfortable, and you get better by making yourself slightly uncomfortable, then it becomes easier. But not every run is a tempo run. Some are easy runs. So you have this pattern. And if you're training to run in a marathon or a half marathon, you change that repetition as you go along. You add more miles and do things. So what about code? I think that there's a lot of, by repetition, I don't mean cut, copy, paste. That's not what I mean. I mean that you find something that it's good structure, like patterns of collaboration, and you repeat how you do this. That you have, when I have some patterns are just like this. If I think about the visitor or the chain of responsibility or the composite, I'm repeating exactly how things work, and each one of those provides a variation. I visit, then if I have work to do, then if not, I pass it, delegate back to an object. When I have the chain of responsibility, if I can't handle it, I then delegate inward. So there's this, do I do something, and then I pass it on. So that's a repetitive cycle that I do that. There's doing work and then passing it along in that case. And domain entities, as I just talked about, can have structures and structures and structures. So it can be like that. So I also think this is a Scrum. This is anybody heard of Scrum? How many do Scrum? Not too many. Okay. All right. I like this. Okay. All right. So this is a slide because I talk about quality in software development. Sometimes people don't know how to do quality in Agile projects because all they care about is just delivering features. But there are these cycles of where you do some envisioning, and then you have a backlog, and then you take small set of tasks to plan stories and break them into tasks, and you have this running a sprint, which might take a week to 4 weeks, and a daily review. And then you deploy and you have some testing and feedback, and you go through this cycle again. And so there are these repetitive cycles. What I find some people forget about when they're doing Agile, just a comment here, is that they think you must sprint all the time. And as runners know, right, if you're just sprinting, you don't run marathons in sprints. So I really hate that name sprint because it implies pacing at a very high rate all the time. But there are these different cycles and rhythms there. Now, so another one of his properties is positive space, where there's no fragments, no code just dangling over the edge somewhere. This garden in Porto. We traveled there for an Agile conference, Alan and I. This was very nice. Now, so there are positive space, if you think about it, in your code as well. Every center has a coherent presence, not a fragment or a bad factoring. That comes from Alexander's quote. What does he mean by positive space? So if I think of objects that have a singular purpose, right? I don't just tack something on like a fragment of DNA. I just need to do something, I better put it in this class. That's just not a good thing to do. I think that role stereotypes that are clean is good. Some may be blended together to make them smarter, but it's well thought out. I think the distinction in positive space, making clear what's the public interface and what's not, is another thing that we, particularly as small talkers, you have to think about very carefully. I think about testing. Testing for expected behavior, what should happen is great. But then also what happens, how should it work when we get errors and exceptions is equally important to create not just the happy path, but the other. Because positive space happens from both the negative and the positive side of things. We have, how many of you heard of do not repeat yourself? Right, that creates positive space. Because anytime you did this sort of repeat yourself with your code, you're leaving a fragment there. Whole objects, now some people believe that when you create an instance, it should be ready to go. And I'm not sure I always believe in that school of philosophy, but there's a style of programming that says in the constructor, pass in all the arguments, make sure it's well formed, because that will be complete and the object is useful. With immutable objects, I agree with that. So the other thing about Alexander talks about local symmetry, where we have, this is again in Portugal, and this was our hotel room where we went to a meta modeling workshop. It was a very nice hotel, and it was so beautiful. There's local symmetries in that they had these. There was what was the port? I don't know. Where's the port on? Anyway, there was some port wine that we could pour in here. There was nothing in there, but anyway. But you see, these are slightly different. The strawberries are different shapes. Different sizes, but there was a local symmetry. So it's not exactly repeated, but it's symmetrical. In fact, that roughness of it is actually an important thing of the beauty. If it looked exactly the same, it would look fake to us or not real. So when you have local symmetries, there's this really wonderful feeling of coherence. It all makes sense. You have this common and consistent naming. Is methods containing the same level of detail. Smalltalk implementation patterns. How many of you have heard of that? Kent talked about that. When I have helper methods that are factored out, and I call things at the same level, and I'm doing the steps in a method that's called from the outside and it has little helper methods, that really adds to symmetry in our code. But even if we're building structuring kind of objects, you think about, well, if I want to have something that has an add and a remove, or a select and reject, if I have a stack, I'm going to push and pop, or I have a do and an undo. These are all symmetries too that we see, the operations. So another property is about good shape. Compact, recursive, coherent centers. So I can talk about good shape, but when I think about a lot of the patterns, I don't want to, they have, you see quite often in certain architectures, you repeat these things over and over again, but you also have well-defined inputs and outputs to things and behaviors. So here's an example, okay, of JavaScript code that I think has some good shape. It's not important that you understand exactly what it's doing. I find in like reading Smalltalk code in and of itself, a lot of the base classes have really good shape, and my code can be somewhat sloppy because I kind of forget these things. So I was surprised, or actually happy, when I was hunting for some JavaScript code, not that I had written. I've written some bad JavaScript code lately, that this had some good shape. And one of the things that's going on is that I'm taking the output and then removing and filtering and adding. You know, I'm doing this sort of cascading, and that leads to good shape in code. Now, this happens to be a set of classes that I developed in Java for a class I teach on enterprise application design, and I'm showing you the class diagram for doing magazine subscriptions with promotions. And I think there's some good shape even in this class diagram and laying them out. But there are two aggregate roots, one about subscription plans that have smaller items and offers that have relationships to plans. And there's some symmetry, but not going back both ways. So sometimes symmetry is in the structures and the relationships between your classes, but you don't necessarily want everything pointing to everything else as well. Okay, so now we're getting into some of the woo part of Alexander's. He talks about deep interlock and ambiguity. And as a programmer, does that scare you? Centers hook into their surroundings. Turns out that this is a picture of a tree. Actually, this is the tree is on the top, and I just flipped it over, and it's a reflection in the water. There's a tree up above there that I took. But this is a picture that Alan took when he was in Norway. See, that's deep interlocking ambiguity. Whoa. In your life. In my life, never. You know. Okay. Maybe in your life. Okay. All right. So actually, this is a park. This is a park where this artist, they let him live. He would make all these sculptures. It's an amazing place in Norway. They're pretty wild and crazy in Norway. Okay, so it's where centers hook into their environment. Okay, wherever the environment is there, and into their surroundings. You know, if I think about it, when I think about collaborations, you know, once we form a connection with something that we're trusting, it's going to take responsibility. We're going to call it. There is some ambiguity. We don't know if we kind of follow the model that we don't want to necessarily always create by name the class of the thing that we are using, but we may get it from a factory that gives us the right one based on the context. You know, I'm thinking of your compiler. We don't know which class it is, but so there's ambiguity there, but we trust that it will be responsible. So that interface and definitions and dynamics, particularly when you're like talking to services, there's a contract between these interlocking things, but there's some ambiguity about who out there is really doing the work for you. The other thing that Alexander talked about is the notion of contrast, that you have centers created by strong boundaries. And I didn't notice this when I was taking it, but I was taking a picture of this foo dog, and then there's this owl-like creature in the tree there. And I don't know. I think Kyoto is full of magic spirits. So one of the things, so I don't have a whole lot to say about contrast. But if all they had was a program where everything was exactly the same, and I don't write code like this, it would be very bland and flat. I don't know. Have you seen students that write stuff? Yes, okay. But I tend to have contrasting things. I have objects that do play these roles. So there is always the contrast there. I'm just saying, I think that all these other properties that we've done so far lead you to have contrast between boundaries. So giving an explicit example was hard for me to come up with. Low contrast, yeah. I think our programming environment at Smalltalk is always high contrast, pretty much. Now, this is actually a field where we went on a walk one spring. This is what our spring kind of looks like. We don't have leaves on the trees yet, but these are daffodils and narcissus. And jonquils, yeah. And it was a farm where they sold these bulbs. But the whole idea is not everything should be the same. That there's gradual variations of quality across the space. And there's a roughness to it that means that it's handcrafted. And this is a stone step again in Kyoto. And the roughness, as we in our life, is adapted to its environment. And if I think about code, I can tell the difference between code that's generated by a compiler or something that's more machine-like than I am. My code isn't exactly the same that I write, even though I'm doing good design. Thinking about it all the time today as it was 2 weeks ago. There is this, over time, I change my depth to what I think is good. We may have a style guide in mind. Some of you, when you program, you have some kind of style. Yes. I will fit in. I try to do that. But even though we have this agreed upon style, and I think that we should tolerate some differences, some roughness. I've worked with people where if my style is slightly different than what they like, they go in and change the code to actually be their style before they start working in it. Have anybody worked with people like that? Yeah. How do you like that? Yeah. Now, if they do it for the whole code base, good. Let's keep them busy. All right. So I think that we need to tolerate some roughness and then have meaningful conversations when it's a little over the boundaries that we consider acceptable. Otherwise, how do we learn? But handcrafting means you don't blindly apply a pattern either. You're always thinking, we're always tweaking things, so there's some roughness there. We might say, well, why isn't it this way here? Or maybe it's just because I was lazy that day, but maybe there were some other reasons. But I expect some roughness. Another property is echoes, in that we want to repeat things. This is a picture of lilies on our pond on a beautiful day, and what I really liked about this picture was, and I didn't know when I took it, I take photos and I go, oh wow, was that the lily pads, and then there's different sizes of raindrops there. It always rains in Oregon. If you come, it will be rainy this time of year. And that there's similarities between smaller and larger centers. So there's a lot of things that we repeat. I've talked about this. And if we don't have those echoes in our programs, we get upset. It's very disturbing when people don't handle errors and exceptions consistently in the same way. That one is the biggest one for me. It's almost like if I walk into someone who does it totally different than the rest of the system, it's like, I don't know how to live in that system. Okay, so this is, it's hard to see the distance in this, but this is Opal Creek. It was named after, it's in Oregon, in the mountains. And you're looking way down, and there's this big green pool of water that's way far below you. And Alexander talks about the void. Right? That's not what you don't return, but it's infinite depth surrounded by the clutter of stuff. So it's something that's clean and pure, and then all this forest is around it. I think that when I think about my code and your code, when I find some algorithm that is doing something elegant, and there's all this setup stuff, and tear down and context, and right there is this nice bit of beauty, I think of that as being the void. Maybe the collection hierarchy, three primitives also. So some of these properties overlap and are there. So the last property is simplicity and inner calm. And it doesn't mean you have to be old to have simplicity and inner calm, but it's slowness, majesty, and quietness with no extras. So if I think about that, the programming languages I use sometimes force to have extras. As I said, I moved from smalltalk to Java. Okay. There's a lot of extras, even in like declaring classes and making things happen. It's not. There's a lot of extra syntax to make things happen. Whereas smalltalk, there is that elegance in the simplicity of the language. But we can also do things to refactor, not just try to use the latest Java 8 things because they're there. I have my friends who say, Java 8, now we have lambdas. Okay, good. Okay.
After 20 years.
Yeah, finally, yes. Whoa, yeah. Ooh, let's get excited. Yeah, anyway. All right. I actually am a fan of simple frameworks that maybe do enough, that are extensible rather than overburdened frameworks. And one might say that some of the, there's debate in the world about the popular frameworks in JavaScript, like is Angular too much? Sometimes interfaces that have a simple implementation, and simple usage, and then if you need to do more, then you can do it. Or something that just works. So if you're building software that just works, I don't have to configure 10,000 things, it just works. That makes me calm, and then I can get on with my work. Alexander talks about not separateness. When a center having deep life evokes a feeling of connectedness to whatever surrounds it. And it's not cut off or isolated. We were in Greece, and this tree was just so connected to the environment. It was just beautiful. It's in a big pot that's kind of cracked as the tree is grown. But then there's this guy up here too. I don't know what he's all about. But, all right. So I'm not going to take time for a group exercise because I've been talking long enough. But I wanted to, this is your homework over lunch. You want to talk about properties, things that make, that you notice. I think one of the first things we have to do is to notice these properties. And once I've now given you 15 properties. I should give that list to people. And you should just go around and look in your environment and your life. When I was in Japan, we had this workshop, and people broke into groups, and we had one group, this is lunchtime, they talked about bento boxes. And all the properties that exist in bento boxes. Do you know what bento is? Where they have the little boxes where they have little compartments for various food and rice. Bento boxes. I did not know so much about bento boxes. It's an art form in Japan. And another group talked about the subway system in Tokyo. To me, I was in the subway in Buenos Aires. I go, oh, where's the intercom there? Where's the void? Give it to me. Oops. Okay, just sign me out of this. Okay. So I think that what I want to say is the first thing is to recognize that these properties can combine and add to create this quality of really elevating the ease and comfort and livability of your life and your code. And the first thing to do is to recognize some of them, not that you're going to become an Alexander geek, but just to kind of look for them, start spotting them and thinking about them, and go, that's why I like it. And that's to my last point, in that Alexander, his first book was writing the 15 properties, and the second book was talking processes that we use to generate lively things. Is that he talks about each one of these has a relationship with us, with me, with you. Each shape is made in such a way that you can establish a relationship with it. Indeed, you want to establish a relationship with it. You want to be connected to your code. Sometimes it's very hard to get connected to other people's code where they haven't thought about these kinds of things. But I can tell you, if you just look at the Smalltalk classes that are there in the base library, you can really get connected to it and be inspired by a lot of very good code. So living structures, whether it's our code, it's our room, it's how we dance, how we make us comfortable, fit their environment, and are made by hundreds of small acts. It's not like I go out and say, well, I'm going to make something, have all these 15 properties. No, I am crafting. And I am seeing how I'm feeling as I'm building this thing, whatever it might be doing. Whether I'm building a practice of running, whether I'm building a practice of writing new code, whether I'm checking in with comments, whatever in my kit, all these things, hundreds of small things. This is my friend Francesco Cirillo. How many of you have heard of Pomodoro technique? He invented Pomodoro. Okay. He came to visit in Portland. He spent time with Word, and he spent a couple of days with me. And we talked about design. Pomodoro technique is where you have 25 minutes of concentration, and then when that time is done, you're supposed to go walk away 5 minutes and then come back. All right, I was not very good at that. He kept trying to time me out, and I wasn't done. But one of the things he did do is cook for me, because he's also has been trained as a professional chef, and so he made something out of squash, spaghetti squash, and he made a soup. And he had no recipes. He'd never seen these ingredients before. He saw, no, you can't make something that tastes like spaghetti. He's from Italy. You cannot make something that tastes like spaghetti out of squash, out of pumpkin, right? There's a squash that has stringy things that I really like a lot. So he made me throw out my garlic and get new garlic because it was too old, So each person in a good process feels responsible for everything. So he made me do the right things. And he did the right things. And he was constantly sampling us. He was tasting a lot. I'm a bad cook, I guess. I never tasted. I just throw in the seasonings. Oh, yeah, it must be okay. Right? So I learned a lot from Francesco. He's really a great guy. But I could not do Pomodoro. So when you talk about process of unfolding, this is kind of something that's interesting to think about, is if you're building something, and agile people try to do this, is that they have a minimally marketable thing. And then they add, and then they add. But at each time that they have a release, it's complete and whole. Right? So it unfolds over time, and each thing is coherent when you release it. Right? That's nice. But plants just do this, if you look at, the process of unfolding starts as an example of a plant. It's one of the things that they say is an unfolding, and we're not there in software, talks about how do we get from there to here, and when a particularly emerging shape should be added. So like here it adds this tail, or head, and here it bifurcates and ends up being a plant seedling. So it's different than a pattern, and it's an important step forward. We're not there yet in software. I think we just know how to iterate, inspect, and see how it feels. We're not there into really generative processes like this. So just want to leave you with, and again, this is a picture of in Kyoto in the springtime flowers, that the whole idea is to create living structures, things where we feel connected. I hope you can do this with your code. Start thinking that way, as well as your life. And so with that, thank you. Okay.
I asked.
Okay.
No, I'm just thinking that maybe is it difficult for you to remember all these 15 properties?
Oh, is it difficult to remember?
Yeah, and right. I mean, just 15, and then you come to thinking about them all the time.
That's a very good question. Do I have to think about all of these? I think if I want to become a student of this, that I do have to know these properties. And some of them are more important than others. You saw that some I didn't, because they seem to be contributing. One adds to another. I think boundaries, levels of scale, certainly this interlock and ambiguity is important with how we write code so that it's more flexible. But probably I might think of 5 or 6 of these, and over time. However, though, when the design patterns book came out, do I remember all 23? Yeah, maybe 10 or 12 of them, right? So about half of them, I do probably remember all of them if I were to take a test. But to me, there's probably a handful of them that are important to understand. Levels of scale, boundaries, the notion of that centers reinforce other centers, and levels of scale, and that we want ambiguity in there, seems to work pretty well for me as a basic set. But I suspect that if you're looking at these, symmetry is also another important one. I don't think you need all 15, but knowing what they are certainly helps. And now, I don't want to do it as theory, like, I'm just spotting these things, but I think the first stage is to just be aware. Why do I like this piece of code, or why do I hate this piece of code? Or why is my life so messy in this area, or why is it so nice? And you'll observe that there are these properties interacting.
So I had a question. I'm no expert on Japanese architecture, but I did take a semester class on art and architecture in Japan.
You're one ahead of me.
I do know.
Yeah.
Well, I was going to say that I do know that one of the things that the Japanese people have sort of they appreciate in their aesthetics is asymmetry. Which is, so to them, asymmetry represents the movement of light.
Mm-hmm.
So I'm wondering, a lot of times when we talk about patterns, we talk about structure, we talk about symmetry. And obviously, there are a lot of ways that symmetry is important, but did you, first of all, when you were in Kyoto, did you see those sorts of symmetries apparent? And two, what role does symmetry play in this sort of picture with Socrates?
Well, so symmetry was one of these properties, right?
Mm-hmm.
But also another property that Alexander has was roughness. Okay, which I don't know whether that unfolding or not exactly being perfect, but I think those two definitely live together. And so seeing in Kyoto, I appreciate roughness. In fact, I don't like things that are just, in their purpose of being beautiful, they're just stamped out and exactly the same. There's something robot-like about that. Excuse me for whoever's going to talk about robots. But it's not real. It's not living to me. And to me, I think that's what you have to do to make robots more lively, is to make them not, to be more, have some more roughness around their behaviors and things. So, I think in Kyoto there were many examples of things that were roughness. I was just taking a lot of pictures and I had no idea, but like a day before our talk, I totally redid this, putting in their properties, and these photos, and they really resonated with me. So it's a very special place, but it did have roughness there too. And I think in design, yeah.
Thank you.
Yeah.
So, first of all, I really
Oh, yeah.
Wait. So, when you were talking about these things and how they relate to real world or life as we know it, I was wondering if at the moment we take these things for daily work, how should we approach this? I mean, I can take these principles and try to look at how they're working and try to look for them, or I can remember myself that building software is like simulating this as became reality, and all these things just like are a consequence of solution. I don't know if you understand.
Yeah, no, I think I do. I think it has to be conscious acts that we need to do to create life in our code. And I don't think it just happens. Actually, Alexander's second volume talks a whole lot about the process of unfolding. And I just touched on it right there. I don't think we understand a lot of that in software, good ways of unfolding. In fact, though, we're getting better at it in that we have this process of test and adapt. And in the Agile world, I don't know if you know a lot about Agile software development, we have this get feedback, frequent feedback and collaboration. But what's missing, I find, from the Agile world is we're not looking at just how do we feel about the code? How does it feel to us, the developers? Do we ever sit and talk about that? Because I remember, when I had nothing to do or when I was not sure how to do something, I would just go look at small-talk code for inspiration of other people who have done that. And I think we need more of that in how we build things as well. So my advice is to not just expect that it will emerge, but to be conscious about small actions, small things. Like whenever you write a method, is it at the same level of detail? There are small things and there are bigger things, but it's little acts that we do. And personal acts. I can do them myself without having anybody else agree. I can just write my code that way. But
do you think the properties could be refactored in terms of well, kind of. Specifically, in the context of, say, having the movie Powers of Ten.
in what?
Of having the short movie Powers of Ten.
Yes.
So, in the context of that, then you have oscillating pattern of something, void, something, void, something, void. And the repeating pattern over and over. Oh, you have things that are always doing something, and more of that, and so on and so on. So it seems to be some underlying structure there that keeps repeating over and over. And some of the things that are repeating are these types of problems. So what's your opinion?
Well, I think that so the question is sort of like, okay, how do I really do this over time and at different levels of scale? And are there other things to do about refactoring these properties or diving deeper? I think that it's going to take some time to figure out some of that. So I don't have great answers. What I do is at whatever level of scale I'm working at, to realize that there's a scale up and a scale down. Sometimes we get lost in what scale we're working on every day, but just to be aware of the up and down might help. But that's not very satisfying. With that, there's a lot of work to be done. Yeah. It is difficult, yeah. I think the other thing that I'm going to do personally is to take a look at some of the functional programming in JavaScript and see whether I can find it pleasing or not to me. Because I can find that in objects. I'm not sure I can in functions. So that's another personal experiment.